Hey everyone, it's Justin again. In the last video, you learned what it means for a number to be rational or irrational. But what happens when you try to put the two together? In this video, you're going to learn what kind of number you get when combining rational and irrational numbers. First, let's get the easy one out of the way, combining rational numbers with other rational numbers. You've never had to worry about this before, because combining rationals with rationals will always result in another rational. This is because all rationals can be written as a fraction. And what happens when you add, subtract, multiply, or divide fractions? You just get another fraction. Now let's introduce some irrationals to the mix. What happens if you try to add, subtract, multiply, or divide a rational number plus an irrational number? First, remember what makes irrationals special. They can't be written as fractions, so we have no choice but to write them as never-ending, non-repeating decimals. But in that case, it's going to be a little difficult to add a fraction to that, so we should probably rewrite the rational number as a decimal too. If we attempt to combine a decimal that either ends or repeats forever with a decimal that goes on randomly forever, we will always get a new decimal that goes on forever without repeating. Combining rationals with irrationals will always result in an irrational. Think of it as the unpredictability of the irrational number getting in the way of the neat, organized rational number. And finally, the tricky one, combining irrationals with other irrationals. Let's take a look at a few examples. First, if we add these two irrational numbers together, we get this value, which we would classify as a rational. So, case closed. Combining two irrationals makes an irrational, right? Well, not quite. If we add these two irrational values together, we get this rational value. So sometimes it makes an irrational number, and other times a rational one. This issue will happen with every operation. Sometimes you'll get a rational result, and other times irrational. To put it simply, combining irrationals can make either rational or irrational numbers. So we can't really make a rule for it. It just depends on the numbers and the operations being used. For instance, this first example we did was actually Euler's number plus the square root of 2. Nothing here zeroes out or cancels, so it just ends up as another irrational. But in the second example, we were adding the square root of 3 plus 5 minus the square root of 3. Square root of 3 plus negative square root of 3 zero out, leaving just 5, which is rational. This is how irrational numbers can somehow combine to create rational numbers. The irrational parts either zero or cancel out. Let's do some practice. We'll start off easy. Will this create a rational or irrational number? We would categorize these two numbers both as rational. When you combine two rationals, you always get another rational. Okay, maybe just giving you the numbers is a little too easy. How about something like this? If we take some number a, which we're given is irrational, and divide it by 10, what kind of number will we get? This means that we'd be combining an irrational with a rational. We learned earlier that no matter what the specific numbers are, or what the operation is, this will always result in an irrational value. Which of these two expressions will be irrational? Both of them are 10 times the square root of some number, but one of those is a perfect square. The square root of 36 is just 6, and 10 times 6 is 60, a rational number. 45, though, is not a perfect square, so the square root of 45 is irrational, and a rational times an irrational will always be irrational. Out of these four expressions, which ones are rational and which ones are irrational? Pause the video here and take a few minutes to see if you can identify them yourself. Let's see which are which. The first one consists of an irrational minus a rational. So that's automatically irrational. The second one's tricky. After all, this is an irrational times an irrational, and combining irrationals doesn't always go one way or the other. But we can simplify this. The square root of a number is what has to multiply itself to make that number. So the square root of 2 times itself is just 2, which is rational. The next one should be easy. It's already a ratio, so this is a rational number. And finally, in the last example, these are both irrational, and nothing will simplify or zero out of the expression. So the result will stay irrational. It's important to know how different types of numbers interact, so keep practicing. Remember, sometimes it's clear what the result will be, but with multiple irrational values, it'll depend on whether the expression can simplify or not. Speaking of simplifying irrational numbers, in the next lesson, we're going to learn how to simplify roots. See you then.